Hi, and good evening, everybody. That is the thing, sound check hasn't happened. Can we do something about that?
Can we put on mute there?
I'm looking. You see mute? Yeah, maybe that one. Down. Like moving a camera.
Okay. Better?
Better?
Yeah, okay. And then no, I still have an echo.
That's all right, it's a bit right.
Okay. Can everybody hear me? Because my voice is generally very low, and when I think I speak loud, then people can usually just so hear me. So shout out if you can't. Okay, welcome everybody to this Melp.net meetup in March 2024. It's actually the first one this year, and it's very exciting. And thanks for everybody for joining. Now I can't actually present anymore. Can the technical guy come and help me present this? No, when I moved the mouse, it started to.
There you go. You're good.
So how do I go?
Yep.
Okay, cool. Yeah, so thanks everybody for being here. Welcome. And this is us. We are Melp.net, .NET user group and programmers and developers group in Melbourne. And for this meetup, we're always looking for sponsors or partners. So right now we have this excellent opportunity of having our meetup here, and we are always happy to have other companies who would be willing to host or willing to provide food for us. So if you know somebody, please help us with that. I find this one very important. We are happy and honored to be able to hold this meeting in and around Melbourne, and we acknowledge the traditional owners of the land where we are meeting, and we pay our respects to the elders past, present, and emerging. So generally, we have a code of conduct. It's nothing outrageous. It's just please be nice, be considerate of each other, and if you need to look it up, there's the URL. We do record these talks, as you've already found out. So if you don't want to be recorded, don't talk. If you have questions here in the room, people can obviously raise their hand, and people who are connected online can post in the chat. And normally there's also like an opportunity for questions and answers after each presentation. We have a YouTube channel, and that's the link there. So most of our talks make it at some point or the other onto YouTube. So welcome to look there. This one is obviously being streamed live. Yeah, we also have swag. You can get something nice like this for yourself if you want to, and that's the QR code there if you want to get a matching t-shirt for this meetup. And this design was made by us, designed by us, discussed by us. So this is Flinders Seed Station in Melp.net with obviously the .NET colors and the big dot that represents the big clock on Flinders Street in the front, and is in the other purple color. Upcoming events. So we're very close to the DDD in Melbourne on 16th of March.
Who's going?
Yeah, I am.
Every time I went to buy tickets, it was sold out.
Yeah, I always go there as soon as the email comes. Yeah, and if you are looking for work or hiring, we are understanding ourselves as well as a forum for that. So both for companies to post here if they have any openings, and for people to inquire if they're available. Is there anything they would like?
Is anyone actually offering work out there from the companies at the moment? I'm hiring, by the way.
Yeah, let me say that if someone wanna speak up and say, if you're looking for a job, then say something. The people online as well, not just people here. If you want to say something, anyone looking for a job? The people, good. You go first.
Yeah, I'm Marcio. I'm software engineer, and from next month I will be looking for a job.
Hi, my name is Etta, and I'm a recent graduate software engineer and looking for software full-time jobs as well.
Nice.
Hey, I'm Mujtaba, and I'm looking for a junior software engineering role, especially one with the .NET stack.
That's great. We can put the comments as well on the LinkedIn channel, with your contacts, and people watching this, they can keep in touch as well.
Yeah, great. So these are our sponsors. Please support them. So tonight we are able to be in the Microsoft office. There's also, we have 2 other sponsors who are here tonight, and where the next meetups will be, you'll be able to talk something about that.
Unfortunately, a bit last minute, so neither of the guys could be here, but Ben Cole from Pinge and Ed Fletcher from Circuit, they're helping sponsor this event, both in the food and swag and other things that are coming. So yeah, we're looking not just these 2, but if any other sponsors are willing to join along for an amazing year, just contact me or Barbara or someone else on the organising group. But the next event coming up,
They can see you.
they can't see me. Oh, there we go. On the next event, it's on the 15th of March. It's the night before DDD in Melbourne. We have like a cool little event, ad hoc event. They both will be here. And again, also Circuit, they're a recruiting company. Great people, specializing in the .NET space as well. So they'll be here with us. And then we've got Aaron Powell talking about generative AI for .NET developers. So that's also going to be a really cool event. And he's going to give a little mini version of his DDD Melbourne talk. So I guess most people missed out on a ticket, so you can get at least one of the DDD talks for free. So yeah, come along on Friday night. Yes, it'll be pretty cool.
And to celebrate, that's Will's
Ooh, yeah.
first meetup as MVP. And I used to be MVP. I kept one for him, and that's it. Let's put a pin here for him.
Oh wow, thanks George. Oh yeah, rip it open.
It's open.
Rip it open. Gee,
And
do they even make these anymore?
MVP now.
Thanks,
You
man.
have to put a pin there.
Yeah. Oh yeah.
Help him.
This is a delicate operation. Wow. Oh. Yeah, how's this gonna work?
Long wait, for him. He's
Yeah,
doing
it was a while.
helping the community for so long.
I might get my finger. Oh.
There you go.
Hang on. Almost got it. There we go.
Yeah. Thank you.
Yeah.
Thanks for everything you have done for the community. Really appreciate it.
Thanks, George. I didn't prepare a speech, but thanks everybody. I guess it's for everyone and from everyone. So yeah, it's good fun. I guess we'll figure out what it really means to be an MVP soon. But yeah, no, it's fresh. Only got
.NET MVP, not just
.NET,
MVP.
yeah,
.NET
yeah.
MVP.
so right at home. Yeah, cool.
And what are you going to talk tonight?
I'm going to be talking about .NET Aspire. So
Yeah.
orchestrating cloud native applications with Aspire and lots of containers in there as well. So pretty cool.
Really good.
Yeah.
You wanna go first?
No. So I think, yeah, Barbara, you can take over.
Yeah, so tonight we will join by the excellent Jorge Arteiro.
George.
Is that George? Okay, how you pronounce your name? To tell us about how you built a Docker desktop extension with .NET. And yeah, very exciting.
Thank you. Gonna go straight for it?
Go straight for it.
Okay.
Plug it in and go.
Yeah, you can switch it off if you want. Keep that for Bill later.
Who even knew that this was possible to write extensions for .NET Desktop?
There you go. You're in here.
I didn't even know this.
Yeah.
So,
Let's
yeah, I know.
let me get a share. See if people can see me from there. Probably can.
Yeah.
Can everybody see from over me there? Okay, let's stop this. I'm going to present my screen. Probably like that. Yeah, people can see my stickers. Share screen. Then where's my screen here? There you go. What you can see there? Not nothing. That's the problem. That's okay. I'm going to show yes code. And we should be able to see now. Yeah, the whole idea of Docker and Docker extensions is the first thing you have to know is about Docker desktop. There's no way to build an extension without Docker desktop. And who's using Docker desktop here for development or DevOps? So yeah, I think the first thing is to talk about. Yeah, if you don't know me, Jorge Arteiro, cloud developer advocate from Microsoft on that cloud native and AKS, Kubernetes, containers, open source space. And last year, Docker gave me the title of Docker Captain. And that gave me it was pretty nice, like MVP for Will. And I was MVP many years ago before joining Microsoft 5 years ago. And now I have the opportunity to work with the Azure Kubernetes Service team, developing those things, and at the same time, keeping the passion for containers, Docker, and it's all really connected there. And for .NET developers, you saw .NET 8 come in and say, oh, we don't need Docker anymore because now .NET can build the image and you don't even need the Docker file. It's kind of, is that true or not? We was also going to talk about .NET Aspire that brings a lot of things on that space as well. But my vision on that is that we still need Docker. We still need a local development environment where we can, build your images. And Docker Desktop now has become more than just running like a container. It's pretty much an environment, just if that's going on. It's an environment where we can manage pretty much the whole thing. Let me just do a quick overview of Docker Desktop here now, if you haven't seen for a while. Before was just running containers and image, pretty much you have containers running. In this case here, that's a Docker Compose file with multiple other ones. You see, that's a student demo, Compose file, and the AKS store demo as well. Then you could get each one of those components, and here you have running locally on my machine, the AKS store demo. Everything's running locally on my Docker Desktop, including MongoDB, including each one of those microservices that are in different language. Means that you can do multi-language development because we are abstracting inside the container your language. It means that on the same machine, without installing all those languages, we could have like a demo like this that's running each one of those components in different language. And then I can even open this GitHub if you haven't seen this one, AKS store demo. And that's the application that's running there. Have Node.js, Rust, Go, Python, Vue, and have Robert Message Queue, MongoDB, and still have OpenAI there. And then we're still able to run everything locally with Docker Desktop. And Docker Compose has been there a long time on Visual Studio. Who's used Docker Compose? Then you're going to see that on the Docker extension, then we're going to use Docker Compose as well. You can use Docker Compose. But you don't have to move away just because you have .NET Aspire or something else, move away from those kind of development. Docker Compose is still valid. You can deploy, for example, Docker Compose on Azure Container Apps on Azure. You can get a Docker Compose and you can push to Azure Container Apps, from your Docker Compose. And .NET Aspire is nice, but just for .NET, define, the definition of the You're going to see that. I'm not going to do any spoiler, William, otherwise I'm going to present your session, but it's kind of just a way that .NET's bringing containers closer to the language, but doesn't replace these. And to run a container, you manage the image. Now on the desktop, you have integration with Docker Hub, and they even integrate with external registries as well. That's where you pack your application and you save that. With using npm, Maven, NuGet, all package management. We store that somewhere. It's the same as a Docker image. It's a tarball, it's a zip file that we pack all the dependencies they call Docker image to run our container. And on Azure, we use Azure Container Registry. Was using Azure Container Registry as the main registry for like containers or something. Azure Container Registry is pretty much a repository, like Maven, like like NuGet and things, but it's more than that. You can run a lot of things inside like a container registry. And Docker is doing the same. They have one thing called now Docker Build, where we can delegate all the build from your local machine to the cloud, and it'll be very fast to build now. Kind of caching on this Docker Build thing. And then Docker many years ago was, everyone know Docker about the Docker command line, Docker engine, but Docker sold that. Docker's not, Docker engine now, the enterprise version is not even from Docker anymore. What Docker sells is Docker Desktop is the Docker Scout, that the security scanning for the image on the development environment. Means that by the time that you're developing something, Docker Scout is scanning the image, and that's what they call Docker Scout. And another thing is build. Every time that you build the image, you do like a command like Docker build, you're going to use that on the extension. That's why I'm talking a little bit about. And you now can see all the builds that you have done. Let's say when I was building my AKS store demo, if I click one of them, I can see all the logs and stats of my build. When you do a Docker build on command line, you're probably going to see all this logging happening. You can see now the performance. Why that's important? Because you're going to build that multiple times, and sometimes that's running inside like a GitHub agent or running somewhere. You want to always make sure that it's not going to take you half an hour to build your image. If it is, something is wrong. And now we have all that information from your image as well. And the most important is the size. Because the size of a container image is like you packing your application. If it's 1 gigabyte, it'll be very hard to install and take longer. Mean that smaller is better. And I have to make sure that you are not packing something that you don't need inside the container image. It could be, you just need runtime things. You don't need SDK inside the final runtime image. And those kind of things, Docker Desktop now can help you to identify those problems very easily and very quickly. And what they did, they said, okay, Docker Desktop is now our main product now. We need to give more, functionality on that. And if you see the settings, they have a lot of features in development, including WebAssembly. Anyone using WebAssembly? That's interesting. If someone asks me today what I should be looking for the next, that's going to be big on the next 5 years, or beginning the next 1 or 2 years, very strong, is WebAssembly. I'm not talking AI. Everyone's only talk about AI, but in development, that to be WebAssembly. Means that it's not just things that used to be on the browser there. WebAssembly now can run anywhere, including on Azure Kubernetes Service, in .NET's also providing WebAssembly now. Then, if you want to play with WebAssembly, Docker Desktop now can run WebAssembly as a container, and you can even mix it up with normal containers and WebAssembly. I did a session on the DockerCon, is on the Docker website, where I was showing that feature, the WebAssembly, and all the improvements that Docker is making to make sure that Docker Desktop can support that. And Another thing that people don't know is that on Docker Desktop, you can create and enable like a Kubernetes cluster. I don't know how to create a local Kubernetes cluster myself using something else. You just click a button, enable Kubernetes, and you're going to have a local Kubernetes cluster running here. And what more? It's very flexible with configurations and things. But let's go for the extension now. They want to extend that. They want to now make this your cloud native environment where you can bring extensions. And if you go and browse, I have some installed here. Let's say disk usage that I think was done by Docker. They're done by the community, and then they're going to look everything that's on my disk. Where's that? My screen. I don't think so because Docker Desktop. Yeah, I could change the resolution of my screen. I can do like this. Display. It's Full HD. I think I'll leave like that. I don't want to mess up. And then we start now building those things, and the partners start, oh, yeah, we can now bring anything inside Docker Desktop. Then if you look around on those are just the approved ones, but if you look on community extensions, there are a lot of things. Like Ambassador telepresence, you can develop in, with Kubernetes remote, and you have like a bridge to Kubernetes extension that have on VS Code. You can have with telepresence. Let's see some things I like. I like that one headlamp. It's a little bit connected with Microsoft. It's kind of, you can manage your Kubernetes clusters. There's a full IDE for Kubernetes cluster. And I think Docker Desktop one. Yeah, but if I enable my Kubernetes cluster, I can manage it from here. I can fully manage with this extension, for example. Docker File Inspector. That's open. Go my button. I think I can. Is that? Sorry. Yeah, we're going to see this demo here. That's my extension, and let me show you that. Not George, Docker extension. There's a Docker file here. If you open this Docker file and view Docker file, build. Yeah, I think they normally, if it's compatible, they're going to explain the Docker file here. That's how this extension is supposed to work. Just example. But let's open another one that's working. This one's probably not updated. Yeah, Docker is building someone things like debug tools as well, and volumes backup. Those are the ones that I'm using. Like volume backup for me is very useful. Means that every time that you create a container, you can create volumes. Yeah, let's say you don't want your files to disappear. You want volumes that you can persist your data. And sometimes you're okay. I want to back up this data. I did something inside my container that I'm playing with a database. I want to back up and export that, and this extension now provide that. You got the idea? Like Docker extension now is creating this thing that you maybe have the idea now about the extension. That's not there yet. And how can I develop this extension? How can I get that's how complicated it's to develop by extension and expose here. I'm looking for a job. I don't have a job. You could create the extension, make your name, and get a job, and tell people that you know how to work with this. There are many reasons to write extension. When I was young, I used to, okay, I see there's an opportunity here, a huge opportunity for for companies as well. And how that works. Let's go for the development, my VS Code. Okay, let's see, I think I delete that. I create one extension here. And the way that they do is, let me probably make this bigger. Can you see it? If you say Docker extension, those are the commands you can do. You can initialize, okay, a Docker extension. Then they're going to bootstrap this. And then if you go, that's normally how you learn how to do things, but the documentation is very good, okay? And then you say Docker extension init, and you give a folder. And they're going to create like a brand new extension for you. Can we do that? Yes, you can. You can do here. Let's create a folder, extension test or extension .NET. And then you say Docker init, Docker extension. I have here this here. Docker extension init, and that to be the folder. I think it'll be like that. Extension.NET. I think they create the folder. That's it. Title for the extension. Extension.NET. Description. Doesn't matter. That's just what they're going to put on the metadata. Go. Then you have to give a name for the Docker image. The way that they pack your image is a Docker image. No, the way that they pack your extension is using Docker image. Okay, then the way I'm doing, I have a Docker hub called Azure tar, could be my name as well, and then I give a name, extension.net. Okay, and then they're going to create, and the default configuration of Docker extension init is using Go as a backend. Okay, they use Golang and they use React on the front end. And that's the point. I want to do it with .NET. How can we do it with .NET? And that's what I start doing. And then in Go, the way that I'm doing here, you need to have to go install. And the way I did, let me go here for my repository. I think where's GitHub? There we go. I got the same idea and I create this extension now in .NET. Then if you look now the back end, that's a .NET solution here. Okay. And if you go on the one that is creating now in Go, let's go open here, extension 1, I think. You can see the same thing, backend and UI, but that's in Go. Okay, if I go backend, then that's the first opportunity for someone watching this is, and for you, everyone here is, they don't have a need for .NET. Okay, you could help them. They're asking for help. They don't have for Python. They only have for Go. Then open source opportunity to create those things for the language. But what I did was I got someone from Docker create one prototype, and then I start from this prototype in .NET, and then I change that. Let me explain how the extension works for you to understand better. That's my presentation at DockerCon. Was the way that they create the extension is, I don't want that. That's fine. We can show you. They have what they call the front end, okay, of the extension. That's a web application. Could be anyone, not just React, the way that they're creating. And that's my next step. I want to use Blazor, and I need help. Someone to help to change the front end as well. And the first thing I did on my extension, I want to create an extension for Azure Kubernetes Service, where we can get all the features that we have on Azure Kubernetes Service, that more than just Kubernetes, from this extension on Docker Desktop. Then I said, I want to use .NET, and I want to engage with the .NET community like everyone here to create, to help to create this. Then when you build your extension, there is a command to build. They package the front end, the back end together. They create a Docker image, and that's the deployment. That's the way that you create your extension, and you give to Docker to create the extension. Okay, and the front end, what they do is they just copy all the files inside your Docker image, and they, when you start the Docker desktop, they kind of inject all the front end there. But the back end is a container. Okay, the back end runs as a container. Then if I go my Docker desktop, I do have extension. This extension that I'm creating here is called Azure Kubernetes Service. That's just the normal bootstrap demo. But now what I did, I create another button called list Docker image. Screen is gone. Let me go back to it. There you go. Still showing. Why is showing this? Hang on. Oh, sorry. I don't know. Let me stop this presentation. That's probably the reason here. Back here. It's live. There you go. I don't need that slide. Yeah, you can go from yeah, you have on Docker Hub the extension now, but I want a Docker desktop extension documentation. Yeah, I think like that. You have these as well here. Okay. Extension SDK. There you go. You have all the architecture. The same thing we showing there before. And we need to pack these things. And this front end can also run commands like Docker, Docker commands. And the way that we did, like this example here, I'm just looking like list Docker image. It's pretty much a Docker image file. If you run Docker image on your command line, but I'm running inside my extension, the extension the front end, they also give you access to the Docker command line. Then if I go back to my code, to the front end that's still in React, this one. And you see, I think it was on the app. Yeah, there is 2 buttons there. I think you can see it. The first one I'm calling the weather forecast, that API, just API. And the second one, they have this thing called Docker client. And you can call, is a JavaScript library, and you can import that here. They also have like a material for the styling to be similar to the Docker desktop. And they have extension API client. And with this extension API client, you can just get Docker. But to call the backend, you also use the client, but use the extension.vm, and you can call the service from the backend API. And the way that they're doing, they're using sockets, and means that your backend, to be accessible, you have to open this socket. And then if you go back to the front end, to the back end in .NET, and you go for program.cs, you're going to see the Unix socket being open here. And that's how the communication works. That's the magic. You have to do this. Other languages are different. You could even open, when you start the application, but here in .NET, you have to do like that. And I'm opening this socket, and my extension itself, let's go back here. There is a metadata on my extension when you bootstrap that tell you where your UI is, the front end, and where's the back end is a VM is. In this case, my back end or VM is a compose file. Means that it's not just one container, it could be multiple containers if you want. Okay, and to build extension, you don't need a backend. If you want just like a web interface without calling, API, if Docker, CLI, or even you could deploy together with your extension, any executable that they're going to inject inside the front end that you can call. And you don't need a backend. You only need a backend if you build more advanced extension. Many of those extensions are just front end. I want to build it for backend. I think there's a lot of things you can do it, like persisting data. Okay, you could have like a local database persisting some data. You could even using some remote storage or something. I want to have a backend. Then my backend is a Docker Compose. Let's see the Docker Compose file. See Docker Compose.yaml is this file here. That means that what I'm doing, I'm creating just one service, and that's the desktop plugin image. That's pretty much create the image from that. And if I go on the extension.yaml, there is metadata.yaml. Those are the main files. And once you bootstrap, they also give like a README file explaining how to pretty much doing the things I'm doing here. So if you want to build your extension, you can use Docker build. They're going to explain, when you bootstrap your application, how you can do even debugging. You can open like a shell. There's a command called docker extension dev that pretty much you're telling the Docker desktop that you're in debug mode. Then say docker extension dev debug, and you are debugging the front end. It means that you can run the extension like I'm running here, but it could be in debug mode, and it could be doing, breakpoints and everything. That's the way that you do, development. Backend is optional, but I would recommend you to look for backend. So how that works? You probably saw like a make file here. To make things easier, you can just say make, like that. That's a new one. Let's go back to my AKS one. Say make. You can do, install. In my case, I have the one I have to update because I have that installed already. update extension. And that makefile, what they're going to do, update extension, they're going to build the extension, run this thing here, Docker build. And after that, they're going to run Docker extension update. That's going to refresh this extension on your Docker desktop. And first thing, Docker build. I'm using the tag Azure AKS. Let me open this here. Then what's a Docker build? They packing your image using this Docker file. Okay, that's going to take some time, but let me look the Docker file here and explain. That's very important because that changed for .NET. I'm using .NET 8, and that's the thing that I worked last week. Was first thing I want to do is update to .NET 8 because got some examples with .NET 5 or 6, and I said now I want to move to .NET 8, and now it's working with .NET 8. Then I got Alpine. Okay, I don't need more than that. I'm even SDK, I'm using Alpine. And what I'm doing here is just a normal, one step to build the application. The way Dockerfile works is like a mode stage build. Each from is one kind of a process. Each from runs as a separate container, and the last from will be the Docker image that will be created. Means that any from that here before this first one, it's just like temporary. It's just like a workflow. I do that, then I do that, second step, third step. And the last from will be the image that will be created. Means that the final image I create is using this .NET runtime, just depths. That means that I don't have the runtime. I'm just building, the application, and then I explained that I don't even know how to explain this in .NET anymore. But if you look my solution, my project, this one. Those are my settings. I have .NET 8. I'm using Linux. That's the only one that you can use Alpine. If you're not using Alpine, you can use with .NET. That's the way that you do using Alpine. And I'm building as a self-contained application. That's why my final image is very small, because I don't need the .NET runtime. And then, yeah, .NET 6 I was able to, do like the trim. For .NET 8, for some reason, the trim is not working, but maybe it'll be working some stage. But it's a self-contained, .NET application. What's nice, because it's very small, and that's what you want. You want to start the extension very quick. And what I'm doing, I'm building the application, normal, backend. By the way, there are some things that I learned from the Docker team that you can do. I don't know if you guys do and do Docker images, these mountings to do kind of some caching for NuGet package. These things makes your build very fast. Okay. But the main thing is I have to make sure that I'm doing the settings there. And just double check because I'm publishing. And I'm not using the new .NET 8 container, generation thing. I'm using Dockerfile and building the whole thing. And one thing that's important here is you have to copy the front end, say copy UI to UI. That's the only thing you do. At the final image, you have this UI folder where when Docker desktop get your image, they're just going to copy this UI folder. That's your front end. They're going to copy that and inject there. But that container that's generated here is not your front end, is your back end. You understand? Is your back end API, but we are also delivering the front end together. That's the way that they found to have one single image with everything together. Looks like that's your front end, but it's not. It's just like a way for them to copy and paste and have this running there. That's the way that works. Then my command should have finished here. Let's say when continue and deploy the extension. They're going to stop the extension there. They're going to remove and reinstall. And one thing they do is like they restart the container there. Then one way for you to see the back end of the extension running, you have to go here on extensions and have to enable show docker extension system containers. Okay, just enable that. If you enable this and you go in containers, I now can see my extension there. I can see my extension, and you see 30 seconds because I just installed again the extension. They stopped the old version and they put a new version there. And if I go back on my extension, now I have the latest version. Okay. Yeah, both operations are working back end and front end. And the development life cycle is that you just now, the only thing you have to do is update your code, make extension, install or update, and you can just build if you want to make sure that the build's working before you install. Those are the 3 commands that you have on the make file, pretty much. Build, install, and update. Those are the 3 that you're going to use more. If your run build works fine, then you install. After that, keep updating. You can enable the debug and debug your thing. And my next step now will be changing this front end for a nice Blazor front end, trying to use this material, styling that they have. And now on this back end, I can do anything that I want. Okay, I can develop anything. It means that if my extension need to save some data, I could have some storage, because remember, I have a Docker Compose file. A Docker Compose file could be multiple containers. The extension, I was stuck with the first container on the Docker Compose file, but that, let's say like your API could be talking with another container. And if you want to isolate, then your extension could be multiple, containers, could have a nice isolation there. And like Docker image that you can now build something and, share with the community, Docker extension is something that you can build. It can be used by thousands of people. I'm pretty sure that there is on extension, if you go create, there are some resources that you can watch here. They even explain the Docker extension init command. I like that community extensions. Then let's open this one. Community extension, and there is even like a forum for you to ask questions how to build. And yeah, feature Docker extension February 2024. JMeter, anyone using for testing JMeter? Look at how many here. Grafana Docker extension. Jupyter Lab. You can on Docker Desktop have a Jupyter Lab, and you can do like kind of a learning Docker with like a Jupyter notebook. And I see the disk usage is very popular, but Portainer is a nice GUI, for Docker as well, that people are using for A's. I think it was a guy from New Zealand that created, if I'm not wrong. Yeah, Octeto, JFrog Artifactory. You could have your container registry running locally if you want. Yeah, there is a lot of, they're probably listing here by, the most popular, and have by category as well. Golang Playground. You could just get like a Golang Playground. That's nice. I haven't seen that. I don't know if you can install from here. Swagger Editor. Means that people bring everything to here, bringing pretty much. What's that? I wasn't able to. Let's see if I can Swagger. Nope. Playground. Nope. Anyway, there's always a link here that you can install, because at the end of the day, it's just like a Docker image. if you have the Docker image, you can just download, do like a Docker pull, a Docker locally, and just install if you want. If you want to test these extensions, if you go for the link, let's see, GitHub. Okay, that's a nice way to learn how to build extensions. Is go on your committed, extension that you like it, and look the code. That's it. The code's there. UI VM, and they're going to tell you what they're doing, and you can look any extension that you want. How they develop those extensions. I'll be my extension that I'm building probably will be here very soon. But that's the way that I learned how to do a lot of things. Following how all the extensions being built, and they're all open source. This one's very old. And the last 2 years, people are developing those extensions. Look, I could be here for a long time, but I'm open for questions. And if someone wants questions, I don't know how long we have, and we have another session. Questions, I want to see. This doesn't make any sense.
It feels like they're using Docker stuff like a canvas, and you can just pick whatever you want.
Yeah,
Is that what it is?
it is that yeah, you can extend like VS Code extensions. You now have extensions there. What I'm discussing here is how to build those extensions. That's not complicated. It's just like one front end. If you want a back end, you can have it run as a container, and you can talk from the front end to the back end using sockets. And also the front end can have access to like Docker CLI, kubectl CLI, anything that you want, even Azure CLI. You just have to deploy the Azure CLI together with your extension. That's the main thing. Then what are you going to build with that? What I've seen is people, like Headlamp that have just these front ends. They just get the same application that they developed before. They're just packing as extension, and they release on the marketplace. And doesn't take long. If you have any product developed already, any idea, you can just pack as extension, and that now be available inside Docker Desktop. And yeah, don't underestimate Docker Desktop, because that's the main product of Docker. They're selling these a lot. And to be honest, I haven't seen anything on the market where you have like full support from a company. Like Docker now is, you have to pay for the professional version of Docker Desktop. And for the enterprise, for companies that really need support for the developers to be doing containers development, still Docker Desktop the way to go. And the investment they put on that is a lot. It's huge. Means that you're going to be able to. They have now bringing test containers. Means you're going to be able to scan your image. You're going to be doing running tests. Everything before we even move your code and think about production. They think about the development life cycle. They're not thinking about only production or deployment. Docker is all trying to fix the development life cycle on the development side. And by the way, we have Docker Desktop now inside the dev box. The new virtual desktop from Azure. It's DevBox, isn't it? DevBox, yeah. So many names that I get confused, but it's DevBox. DevBox now, you can install, you have Docker Desktop can burn inside DevBox. That's pretty much a virtual machine on Azure. That many companies use a virtual desktop. And if you get a job, maybe they're going to give a DevBox. And then you're going to ask, I want developer using containers. Okay, you can now have Docker Desktop running inside the DevBox. And looks like a simple thing, but trust me, I've been doing development for many years, and it's always the first thing that block the developers is they don't have access to virtualization on the machine. If it's Windows, they don't have Hyper-V, they cannot create VMs. And Docker, depends on that. Depends on some features on Linux, on Windows that if you don't have access to that, very hard. If you're not admin of your machine or something. And now with DevBox, I think it'll be easier to to onboard new developers. Okay, that's it. You have a dev box, you have everything that you need, including, Docker desktop. You can develop for containers. Makes a lot of, difference. I cannot tell the stories that I have for for some customers that I work with for Microsoft. Consulting myself is kind of, you cannot do your job. If you don't have access to create a container, to run a container, even to create micro VMs, how are you going to test all these new technology that depends on those things? Then if you are an enabler, if you are a manager, if you are staff engineer, someone that building those things and trying to create those environments for your team, you have to think about that. And that's the conversations I have with customers is always, we don't have an environment, the team don't, they don't have Docker desktop, they don't have even Docker on their machine. How can I develop for Kubernetes if they cannot do anything? Okay, and then people just give up. People just give up. And now we have a WebAssembly as well. That's the next step. I'm pretty sure if you come here next year, it will be a WebAssembly talk. And we'll be talking about how you're going to now move from milliseconds or even 1 second to run a container to microseconds, like be less than 1 or 2 milliseconds to run a WebAssembly. Pretty much instantaneous. Okay, and there is no dependence. You can just run. I'm pretty sure you're going to talk about that very soon here. Any question? More questions?
So you said that the backend you can avoid the backend and do the UI, right? It is possible to do it the other way, like just extend the CLI.
No, you need the front end. You need at least one, because every time that you click on that extension, they're going to refresh it's kind of like a full refresh on the browser to open your website. That's pretty much what they do. There is no caching. If you want to create some state, there are two ways: is the backend, or you could use, local storage. You can use local storage. You can send documentation. They're going to give you local storage. But then when you close the Docker desktop, it's gone. Okay. If you want to persist between you close it and open again, then yeah, you need a backend to store somewhere. But if you want to just persist, when I click on another extension, come back inside the same Docker extension session, like a browser, moving tabs, yes, you can. Then you have to make sure that the extension is like JavaScript fast, and React is pretty fast. I don't know others, and that's it. Let's go for Will. Thank you.
Right, maybe you'll take a 5-10 minute break. We'll get set up, and then we'll do the next one.
And people here online, how are they going to take a break?
How do they take a break? Well, get off the chair, stretch around,
Cat video for
get
a couple minutes.
No.
moving, do some push-ups. Yeah, hang from the wall somehow. All right, so how do I get my screen?
We're going to be back soon.
Yeah, can I directly share to that screen? I've got my own little laptop.
You can have these as well.
Yep.
We're going to listen to everything you're saying.
Yep.
No.
So I just want to see if I can get the HDMI directly onto that screen.
Chromium browser inside.
Docker desktop.
No, not gonna start.
It might be. It really might be.
Mhm.
Yeah.
Okay, let me put something here back. Let's put here. Okay,
How many we got online?
back in 5 minutes.
Yeah.
Can I go out? Use the washroom?
Yeah, of course.
Someone
Yeah.
has to open the door.
Yeah. Don't worry. Someone will open the door. You'll be fine. Oh, I need battery. Welcome back, everyone. Hey, hey. Works?
Yep, go ahead.
Go ahead. You're echoing, I'm echoing. Okay, all good?
Yeah, but
All right, excellent. Okay. There might be some people still coming in. All right, give them 5 seconds. Notice George's got some stickers, or someone's got some stickers on the table there. Go for it. You always need to decorate your laptop. I've already got some, but not on my laptop. Might need to get someone to help me decorate it. Yeah, on the way out, just slap one on.
I have some
Back in your shirt.
Yeah. Okay, cool.
Before we start,
Yeah.
I have books here.
Oh yes.
You probably don't have enough per month, but let's make people jealous online. I need your microphone.
Yeah, this is pretty cool. So
Yeah.
you've got some Kubernetes best
Who
practices.
wants Kubernetes book?
Yes.
I
So
don't think I have per one, but
all right, you ready to catch?
who wants to run for? Who runs first?
Like the
Yeah.
bartender style, just slide it across
That's
the
it.
table.
That's
So yeah, I guess
people line there.
Brendan Burns. Who else is there? Yeah, Eddie, Dave, Lachlan. They're all there.
Brenda Burns is the Kubernetes creator. There are other people here from Lachlan Everson from Microsoft. Eddie used to be from Microsoft. They're all Microsoft people.
Yeah, definitely a good read. I already started reading my copy.
Yeah.
So quite good. Okay, so tonight I'm going to talk to you guys about cloud native app orchestration with .NET Aspire. Now, who's already using Aspire? What? All right, I think after tonight you'll probably want to wire it into literally everything you have that runs .NET. So we'll talk about .NET apps being orchestrated with Aspire. You'll see what that really means. And eventually we're going to go and deploy that straight into Azure Container Apps. It's like a really natural fit for me. Now, when I'm talking about cloud native apps, it's an app that's meant to run in the cloud using cloud services. It's not just really running on your local bare metal. But .NET Aspire is all about the local development experience. And as we'll see, it doesn't actually care or have any concept of what deployments are to the cloud. So it's weird mixtures of stuff, but it all makes sense pretty soon. So my name is William Liebenberg, a solution architect at SSW here in Melbourne. And over the weekend got announced that I'm a .NET MVP now, which is cool. Thank you very much. So I had to quickly update the slide and put that little logo on there. And the pin, yeah, thanks George, that's a cool pin. So you can get hold of me on Twitter. I've got a blog that is severely out of date, but I do promise to update it one day. You can get hold of me on LinkedIn. I started coding a long time ago, or at least pretended to, on old basic language, if anyone knows what that is. And Spectra Video 328, so that's for the really older guys that might know, when all computers were beige, pretty much, and running off tapes, long before CDs and internet. So, yeah. But then, long time later, I started doing 3D game dev with C, C++, which was super cool back then. But then .NET came around. V1, I thought, what's this fancy new toy from Microsoft? It's not going to last. V2 came out. I was super impressed. I've pretty much used it ever since and built my whole career on .NET. Same with Azure. Started using it quite early on. And pretty much now, every day, this is my daily stack involving a lot of Azure, .NET kind of stuff, and now also adding Aspire to the mix. So distributed apps or microservices, pretty much almost most of our apps now are distributed apps. It's not just one single app anymore. It's your app, another service or a background job, a dependent service like a SQL or any queues, whatever. There's a lot more to our apps now, especially in the cloud, than just one small bit of software. And along with that comes all these problems, the complexity of the software, the business logic inside of it. The discovery between your services. How does one service know about another? So you have to configure host names and ports and routes, all that kind of stuff, so they can talk to each other. The dependencies in our apps, the libraries we add, and even the way, the dependencies of who communicates with who, all of that. Debugging, deployments, security, all these things, observability, all these things are painful. And especially with microservices, for each new service you add, you're compounding all those problems again and again and again. And so, yeah, it sucks. Distributed apps is not easy. But we're going to look at Aspire and see, it actually deals with a lot of these things for us. It's not going to make apps cheaper to run, in no way. I did say it doesn't deal with deployments, but we are going to look at what it produces to help with deployments. And service discovery, dependencies, debugging, resiliency, and observability really is something that we're going to get for free out of the box with .NET Aspire. So it's just a whole bunch of awesome tooling that's going to help us with our local dev experience. So imagine you've got 3, 5, 10 more services running on your local machine. They all have their own database. There has to be a queue, a Redis. You have to make sure that all these containers, all these apps are started, they're configured correctly, they can communicate with each other. And then you want to run your service, you have to F5 in that to be able to debug it. So there's quite a lot of steps you have to go through to be able to get started. Right? You are orchestrating everything manually to start your application. So orchestration, main thing. Components is another cool thing that Aspire brings. So things like a SQL Server or a SQL Server run with EF Core, Postgres, Cosmos, there's a whole lot of options they're adding, making it easy to wire in sort of these cloud, specifically Azure ones at the moment, into your application. So it's easier to add EF Core. It's easier to add a service bus and a Redis and all these things to your apps than it has ever before. So we'll see some examples of how to do that for real. Observability, big thing. So when you deploy your apps, it goes into cloud, and you've got App Insights or Prometheus and Grafana, like something set up there, so your APMs are set up to look at your app, see what's happening, so you can be proactive in fixing issues or noticing issues or trends that aren't great, rather than reactive. But then when something did go wrong, you have to try and replicate this locally, and you have to rely on the logs from production, but your machine is nothing like the production machine. So observing your app locally is also not the same as observing it in the cloud. And you can have a little bit of App Insights through Visual Studio, but it's not quite the same experience. .NET Aspire actually comes and closes that gap for us quite a lot. And other tooling is just being able to add the Aspire capabilities to an existing app as well, which makes it quite nice to use. And there's actually a whole lot more coming. Like I said, it's about the local dev experience, but I spoke to some of the .NET team while I was at NDC, and they're actually going to move into other areas as well for, provisioning cloud resources as well from your local machine for your local app. So, you might need a real Azure Service Bus rather than running some sort of RabbitMQ or an emulator locally, which there isn't an emulator for Service Bus currently. So, a bit of a problem. So they might actually make it so that when your local app requires a service bus, it can go and provision one for you. So some cool quality of life improvements coming in the next version of Aspire. But with the current one, the promise is that one click starts everything. I'll show you what that means, because that is true. So you can actually start projects. So if you have in your Visual Studio solution multiple apps, multiple backends, front ends, all that, instead of running one by one, you can start them all at once. So cool, that's projects that you own, that you have the source code for, but you can also run other executables. You might need to run, I actually can't remember what a good example of an executable would be, but you might run a node command or something to prepare a script or set something up before your app runs. So you can do that. You can even run other containers. There might be containers that you've built as part of another project that you can use for your app. And it's already published to Docker Hub or the container registry. So you can actually wire that into your app, and your app, or what we call the app host, can orchestrate that container, make it run before your app runs. So pretty cool. It's all going to come together in this one fancy dashboard. You can see all the resources that you're spinning up, the details for them, all the configuration. You're going to see how, if you imagine you've got multiple apps running, getting the logs for them be in different console windows, or you might have to set up something that pushes to seek or app insights or whatever. There's a lot of work for you to do normally, but with Aspire, you're actually going to get it all in one place, as well as trace logging or distributed tracing. So we can actually see requests going from one app to another app to another app to another service, all in one place. It's very cool. And some metrics, which gets even cooler. We'll dig into that. So demo time. So I'm going to go and open up Visual Studio. Now, before I actually show you the one I've got pre-prepared, I'm going to show you how to create a new project with .NET Aspire. So if you've updated to one of the latest Visual Studios, you can actually get one of the starter apps, right? It's pretty cool. You can do this all from the command line or on Mac, Linux. Just go and check out the docs page for installing all that workloads and the templates. But Visual Studio is your best friend, and you can go create the starter there. I'm just going to call this Melbourne, if I can type correctly. I'm going to call it Melbourne.net Live Aspire. There we go. And really don't have to do much, apart from tick the box there and say I'm going to use Redis. And because containers are involved, you do require Docker Desktop. I'm just going to make sure I've got it here. Yep, it's there, it's running. Okay, create. Okay, so here we've got a new project. Can you guys all see that on the side there? It's not too small. Can you read the screen? No? All right, let me just fix that real quick. Nice little trick in Visual Studio that you can actually make all of that stuff bigger. That one. Let's do that. Is that better? Yep. All right. So the thing you'll notice is with most Visual Studio templates, you get a weather service. Yeah, they really care about the weather. So here's another one, which you've seen many, many times before. There's a couple of things here about adding service defaults and mapping default endpoints, but I'll get to that. We also notice here's an app host project, which is a very important one. There's a service defaults project, which is a bunch of extensions. I'll go through that. And then we've got a Blazor front-end application that, if we look at the code, sort of talks about this weather API client. So we can imagine that it's going to consume that weather forecasting API in the background, but noticing the host name here is a little bit simplistic and doesn't quite make sense. But the reason is this app host is going to be at the core of your .NET Aspire application. And this is the thing that does all the orchestration for your system or the project you're building. And like I said, there's three things you can add into here: projects, executables, and containers. So first off, they've already wrapped up, for instance, a Redis dependency. So we can go from this distributed application builder. You might be used to the web application builder. Now there's a distributed application builder. So you get that builder, and we create a cache, calling it cache, we're giving it a logical name. Okay, underneath this, really what it does, you start drilling down, it goes add a resource, it's of Redis, it's a Redis resource, and underneath, to dig further and further, it basically goes and pulls down the Redis container and run that with your Docker daemon. Now, here we can go and add another project. And this is actually using sort of a code-generated name for that project. If you F12 on that, you can see it actually points to the project path on my local hard drive, right? Okay, so I've got a strongly named thing. Is that on? Yeah, I've got it. Okay. Yeah. Is it working?
No, I thought it just, no, that's fine.
All right. So you get a strongly typed object here to represent one of our projects. So this is with the API service, this one here, all right? Okay, and so I get a reference to that, to API service. Now at the bottom here, I add another project, which is my web project, or the front end project. And I'm adding a reference to cache, because in this example, I want to use Redis as an output cache for the front end. So, you know, people on your e-commerce site waiting for a ticket to show up, the F5 smashing that button, you know, Redis will stop that for a little bit before it hits the back end. But eventually, you must make a call to the back end, so we're using adding a reference to the actual API service. So here you can see you're building up a little application graph of, you know, your main app and its dependencies. It's quite, you know, straightforward for now. But really, if we look now, three things here. We've added cache as a logical name for our Redis service. We've got API service, again, for the weather service. Could probably rename that to weather service. Let's do that. So if I go here, rename weather API service. No, just weather API. Let's make it less noisy. Okay, and it's there now. But if we go back to Aspire, that doesn't work. Oh, why not? Okay, so we can actually see now, there it is, co-gen the right thing. And if you look at the API service here, project references, you have to have the thing added as a project reference as well. Okay, so that's how app host knows about all these things, and then can do the co-gen and wire things up properly. Now, I'm just going to hit the run button and show you what you get. It's pretty cool. And usually it goes pretty fast. I should have all the containers loaded already. Standard issue console window, and here is .NET Aspire dashboard. All right, I'm going to zoom in a bit. So what you see here at the front, at the start, is all the resources that we've spun up. So here's all things that we created or described in our app host. So we've got the cache. You can see it's a container, and that's the image that it's running. It doesn't have an endpoint for us to access directly, but you know, we can go and look here at its logs to actually see the logs, which are actually the same logs that you'll see if you go to Docker Desktop. And this is that cache instance running in Docker Desktop. I went a bit quickly there. There's that one container running 46 seconds ago. So it's the same logs that from the container are now displayed here in the Aspire console, dashboard. But you can actually go and drill a bit deeper and look at the other sort of details about this container, right? Environment variables, a whole bunch of stuff. So it's kind of cool. It's all in one place. Our API service, or weather API, I can actually see that it's a project, one of mine, it's running. So if it didn't start up, and get a little red cross there. But I can hit the endpoint, and that basically just gives us a JSON payload, right? That's what that API does. That's all it is. If you look at the code here, we go to our weather API, just one endpoint / weather forecast. Okay, oops, wrong one. So yeah, when we hit / weather forecast, that's all we get back. Cool. All right, pretty straightforward. But again, I can see its logs, and I can go and see the details about it. So you can see a bit of configuration here already. All the environment variables, a bunch of new weird things that we never configured. But I'll get to that. Then the front end project, the nice fancy one. We hit that URL. Here's our Blazor app, and you know, everyone needs a counter to click on. But if you go to the weather, we see here is the weather information. Okay. So let me see if I can put the side by side. I'll actually run that next to, run that next to Aspire. It's going to get a little bit cramped, but I want to show you something. So now with the console logs, I can choose any resource I want in my list. So let's say for the web front end, you can see here, if I go and F5 on that, it's a bit hard to see, but you can see that the logs are spinning around. Every few seconds, I might get a change because it'll time out after 5 seconds and reload the cache. Oh, there you go, it changed. So there's that. Or I can look at the cache. Yeah, there's a little bit of activity there. the web, sorry, not that one, this one, not much happening. But I can go and look at the trace logs. So, and this is all live and it's all kept in memory, right? So just be aware that once you stop Aspire, all the stuff goes away. It's not persistent anywhere. So you can actually look at these trace logs, sort of structured logs, and click on it and get all the sort of nice, rich details you would get. If you're used to like app insights and seek and all that kind of stuff, it's very similar to that. In fact, you can extend Aspire with Seek as well. But yeah, I haven't got that demo set up, but that looks pretty impressive. Now, when we look at traces, this is really nice. So if we go back to the beginning, you can see here's a trace to hit the API service, which I manually hit that / weather forecast endpoint. We can see here timings of all the requests underneath that. And if I go back, I can see here I just hit the web front end a fair bit, and whoop, yeah, same sort of thing, but not too much happening there. But here we can see now there's two. So when that front end cache expired, it then reached out to the API service, and we look at this. Oh, this is a bit more interesting, right? So we can see that. Let's make that a little bit longer. That the cache came back, but I had to actually then end up calling the weather forecast as well, and then because that cache was invalidated, I resaved it here. So you can actually see all the steps of the request. It's traced through multiple services, and now you can observe that. Didn't have this before, right? This is all out of the box for free. And then you can go even further. If you have a more complicated app, you'll see longer traces and a whole bunch more interesting things. But metrics. So does anyone know performance counters like Windows or iOS kind of stuff? Yeah. So similar to that, if we look at these metrics, not that this app is doing much right now, but you can look at the metrics collected about the web server itself. So here ASP.NET Core hosting. If you look at the actual Kestrel underneath, you can look at request durations and how many connections have been queued. So if you're hammering or load testing this locally, you can see what's going on. You can go and dig through a whole bunch of stuff of .NET and look at the garbage collection, how much garbage there is, and how many times the collections happen, for instance, etc. There's a whole bunch of stuff in here that once you really need to fine-tune or do some archaeological digging, you can go in and find out what's wrong with your app and fix it. We just haven't had this up until now, right? Like, if you really wanted it, you had to work hard to make it yourself. So now it's all for free, out of the box, which is really, really nice. Okay, so I'm going to stop that one. We don't need that anymore. And close this. Okay, and this is all running locally, right? It's not, doesn't need anything special. It's just running straight off my local machine. So who's going to use Aspire now? Yep, most people. Cool. Yeah, definitely awesome. So what I did was I went and just sort of pre-prepared another demo, show you a few more of the things that's possible. Okay. Now, like I said, you can actually add Redis as a cache layer, but if you look at what's here, I'm going to go back a step. So when you have the builder, big enough, make it a bit bigger in the back there. Yeah, make it a little bit bigger. Okay, so when you have builder dot, and you can actually see, I've already added an extra NuGet here, which is the Aspire Azure hosting, or hosting.azure, all right? There's a few other things you can add in there. But so now I can add in a requirement for Cosmos DB or Key Vault, OpenAI, Service Bus SQL, a whole bunch of them, or just a plain container. Kafka, Mongo, MySQL. You can add a Node app. You can even run an NPM app from here, right? You can actually make a whole bunch of stuff start up with your application. Oracle even, how did that get in there? So if you look at, there's a lot of opportunity here for you to go, oh, I'm going to build an awesome cloud native app. Yeah, all these are all cloud resources that you can use for your application. Yeah, RabbitMQ's there, etc. So what's nice is before we saw we can add Redis, but we can add a bit of a nicer little extension to that is once you have this Redis resource, then you can have a few more bits and pieces with it. You can add annotations. You can add an endpoint to say access it on this port, for instance. You can override the host and the container port numbers if you wanted to. You can add environment variables and a whole bunch of stuff. Or you can add a Redis commander, like let's add another container. Why not? Because when you have Redis running locally, how can you inspect your cache? You need to use one of those tools to get in and explore your cache. And they've just wired in Redis commander. But if you have another one like Redis Desktop Manager, or I forget there's a whole bunch of them, and if that runs as a container, you can then just do add container. Oh, not there. Sorry. Do it separately. Redis, whatever. You can actually use the add container method, and with that you can give it the image name, a logical name, the image name, and then there's also like a tag, so you can do version, whatever version number you want to use. So choose a specific container if you need it. So what I've done here, just I've grabbed one of the sample APIs instead. So I give it a name, sample API, because everything has to have a logical name. And what this does is, which I haven't shown you yet, is it works out through service discovery this logical name, what host name and port belongs to it, and then it announces that to, or configures the other apps to know, this sample API is running on whatever IP, host port 8080, container port 8080, right? And so, yeah, I'm just saying what image to use and the tag to use. And I actually, because it's just a random container, I actually have to tell it as well what endpoint is available. So how would other apps be able to talk to it? Or where can I talk to this container from other apps? So I give the endpoint a name as well. And so I just grab a reference to this endpoint. So here I've created it, but I still haven't got a reference to it. So I'm just going to get a reference to that endpoint. And for some reason, I wanted to use Cosmos DB, but there's something wrong with getting the certificate working locally. So I had to skip that one, unfortunately. And there's some more stuff in Preview 4, which I'll show you about a little bit later. But let's say we want to also add a SQL database. But true to containers, every time you run it, you shut it down, it's ephemeral, it goes away. So you need to add a volume so that when it starts up, you replace part of the Docker file system with a local mounting, so that anything that is written to that location in the container actually persists on your hard drive. But in that scenario, you need to have a consistent password for that SQL database. If you don't give it a password, it assigns a random one each time, and that volume, like the way the checksums and everything works, is you're going to get a new volume each time. Not great. So give it a fixed password. You can just bring it in from your config file. So I got here somewhere. I got it. Oh, where did I put it? Yeah. Oh, sorry. I used user secrets. There you go. There's my password. 123. A bit more complicated than usual, but yeah. So in that regard, here now I've got a SQL Server container running, and it's mapped to a local volume. So each time it starts up, I get my old data back. Now you can go a little bit deeper and override a bunch of stuff. So you can even say replacing the entry point script with one of your own as well. Oops. Yeah, if you want to run, I don't know what I just put, run some migrations or any sort of preparation work for that database, you can do that. But I don't usually have a need for that. I usually do that through my .NET apps anyways, if I need to seed them, etc. But yeah, if you needed to, you can. So the way that you're, or pre-create users and set up some security, all that. You can do that with your own sort of a startup script. So now I've also got a SQL server. Now I can actually add a database as well. So this can go and create the SQL database on that server for me. So you can see here I've got SQL dot. You can add a database and do a bit more extra configuration as well, which is quite nice. And so far we're actually, we're setting up things that we need. And here I'm adding the reference to my weather API. It needs to store some stuff in SQL. And then same sort of front end app. I'm telling it, hey, here's the cache that I wanted. Here's the weather API as well. And then here's an endpoint to that sample container that I spun up as well. All right, so we're not adding the container directly to my web app. I'm adding the endpoint to the web app. All right, cool. So what I've done as well, you see with these weather API logical names, so in the web app, when it starts up, when I wire in a HTTP client for this weather API client, I'm using that logical name. So the service discovery will take care of getting the right configuration to each of the apps so they can talk to each other based on that name, which is quite nice. And we'll see once we spin it up, it'll actually have the real host name and port number there for us. But in our code, all we care about is this logical name. So if, for instance, you redeploy this to another environment or another machine or whatever, you don't have to change your code because the service discovery will just kick in and work it out for you. Yeah, so one thing before I spin this up again, right, I want to show you the service defaults. This is what we spoke about before. So for each of the Aspire apps, you'll see that it's got this add service defaults call, and a little bit later sort of add default endpoints. Now what the service defaults is, oops, nope, doesn't like that. Try that again. What's going on? F12, nope. Try a different project. Let's try this one. It should all work. Maybe I haven't built yet. We'll see. Yeah. Let's just build this project. Maybe it's run out of... Yeah, something's gone funny. I don't know why, but whatever. We'll just go straight to it. All right. So for that dashboard that we saw to work, or for our applications to work with that dashboard, they all get OpenTelemetry configured. So all the logs that it produces, they set up a OpenTelemetry server or listener on the app host. So everything that we write goes there, and then they can surface that in the dashboard for us. Everything gets default health checks, so they actually can ping the app and sort of see if it's up and running. That's where that running status comes from. And it's just a very basic self-check. Hey, are you there? You're live. And then we add the sort of service discovery, which is a little bit more involved, but that's the thing where it helps for the apps to be able to discover each other. And there's a fair bit to dig through, but it works. Now then also we can add some resiliency out of the box. So has everyone heard of or used Poly before? Yeah, nod. So it's a pretty cool library that gives you the ability for retries, circuit breakers, bulkhead operations, that kind of thing, so that you can have an application rather than if one operation fails, it can retry, be a bit more resilient. Try a little bit harder to stay active, get that request that you've put in to go through, rather than just suddenly giving up. And so they've baked that into .NET. I think they've actually forked Poly now and worked with the Poly devs to make like a zero allocation, memory allocation version of Poly, so it's very performant. And they've wired that into .NET as well. So there's a standard resiliency handler that you get, does a bit of rate limiting and so forth for you, just the default, sensible defaults. You can override all of this as well, right? So you can see here, rate limiting, timeouts, circuit breakers, number of retries as well, or timeouts for a retry. So not bad, but you can actually go and add a different one. There's a really cool one that I found out about the other day. There's the there you go, the hedging handler. A little bit extra work to be done, but kind of like you're gambling, you're hedging your bets, because you can actually have two or multiple services to call out. Yeah, you can send out those requests, 2, 3, 4, however many you configure, and the first one that comes back is the one that it picks and reacts upon, discards the rest. So that's kind of cool. If you want a highly available, resilient system, you can use this standard hedging handler, which is pretty cool. But yeah, you need to go and set it up, and there's a bit of work to do that. But the documentation page on it is actually extremely well made, well written, so you shouldn't have a problem following that. Again, just turning on the service discovery, you can see how they configure open telemetry. You got for gRPC apps even, if you do that, it'll work. Then yeah, just a bunch of other stuff, health checks, and just adding those standard meters. And you can add your own meters for your app, publish your own metrics as well, and then enrich that sort of dashboard view with your own information. Okay, now back to the main app. I must have changed something somewhere. Yep, hang on. Let's just undo all that, just in case I made a typo. All right. So when you then also created a new app, that tooling I talked about, here we go. So you can actually add a .NET Aspire component, and for now it just shows you the available NuGets. So you can actually add in, if it comes back, I think it's a bit more than I expected. It should actually filter down to the Aspire stuff. But yeah, you can add in, if it was the right list, Entity Framework, Core, or Cosmos DB, all those. This is not showing me the right list of stuff, I believe. I'm sure something's gone wrong there. Yeah. All right. I guess it happens in preview now and then, right? But the other thing you would get as well under this ad is, and I think it's just worth showing you real quick what the tooling is like. Let's go here, and I'm just going to add another project real quick, just a standard web API. Call it another API, standard things. Now, broken UI, you can't enlist this in the Aspire orchestration for some reason, even though, yep, okay. So now I've got another API here, and we see it's pretty standard weather service again. But if you had an existing project or a bunch of services, you can add Aspire to it. So you can add the Aspire orchestration support. All right, and it just warns you, hey, I'm going to modify your code, so be careful. And when you do that, it goes and creates, obviously I had the app host there already, but it's added this call to service defaults, and it's figured out where to add this map default endpoints call for me as well. Usually just after the builder.build. And that's it. So now we also look at the app host. If we look at its project references, it's automatically got a reference to another API, and it will then become available in here. So if you want to do builder dot, it's already done it here. It's already added the orchestration to it for us. Okay, so it knows to spin up this API along with everything else. Cool. Okay, so that's that tooling bit. You can do all of that again with the CLI, but yeah, I'm going to use Visual Studio. All right. So on my web app that I've got here, showing I'm using the SQL server component. So this is the web one. So I'll just show you here. Wait, that's not that one. The weather one. So I added the Aspire Entity Framework Core SQL Server component. So that was supposed to have been via right-click add component, but for some reason the NuGet browser is showing the wrong things. But yeah, you can just go and look. This is looking better. Yeah, sorted itself out. So you can actually go and choose many components. They've already got stuff ready for .NET 9, but you can change that to go back to .NET 8 as well, right? And so you can put in Postgres, you can put blobs or whatever. So as long as you've added an orchestration call for storage blobs in the app host, you can then add that component, providing you've got the right NuGet, you can add that component here quite straightforward. So it's just adding SQL Server DB context. I don't really have to do anything else. Right, all the other SQL Server or EF core dependencies are in there for me already. Same with if I had Cosmos DB working, just add Cosmos DB and give it that logical name that will hook it into the app host orchestration. Okay, so a bunch of wiring up and things to do. My web app, like I said, I've got a weather API. I've also got the sample API that I'm loading from just a random container, right? And I've really not modified anything on this app other than I went and created a page just to show some information coming back from that random API. Okay, so let's just F5 that, fingers crossed, didn't break anything. And boom, spinning up everything, start running. That was nice and quick, right? Much quicker than me having to start everything up every time. So I got web front end, weather API, SQL, random container, I got Redis Commander. Without doing anything, bang, there's a cool app that I can use to inspect my cache. And obviously, yeah, all the logs, everything that I want are there straight away. So Redis Commander, yeah, this is straight just the Docker log, so it's quite nice. I see my database is running, excellent. And so what I'm going to do is going to get these traces up for everything, cool. And oh, hang on, I'm just going to open up the web UI application, run it side by side, and go to traces. There we go. Already a few hits on the front end, and I can happily skip the counter. So you can see here, this is live. You can see we hit the weather API service because it didn't have anything in the cache. But now if I hit it a few times, nothing's happening because the cache hasn't timed out yet. And eventually, bang, there's another call to the real backend. Awesome. Now the sample API, wow, here we go. Now because this is a random API that's not been, that doesn't have the service defaults from Aspire or anything. It's just another container, could be a Go app, whatever. So it is not configured to ship its logs out with OpenTelemetry into our app host, right? But you should still be able to see that at some point, a bit cramped, that I made a call to that API as well. So it does still show up in the trace, but it's not quite as rich as what you normally get. But you still get all the really good information to figure out what it did, and when it did it, how long it took. So quite nice. Okay, then that's it, right? I've got here a distributed application. I've got Redis, I've got SQL Server, I've got random container, I've got another API, and basically developing a microservice or distributed app locally. One click starts everything. It's quite nice and easy. Plus, very importantly, you can go and still debug everything, across multiple APIs. So if you set breakpoints here before you started, I don't want to set it now, for some reason. Right, so you can debug your apps, usually. I don't know why it doesn't want to work. My Visual Studio is not having a great day today. Can't F12, can't debug. But yeah, normally you can just hit a breakpoint anywhere in your multiple services, and you can debug across multiple services. So it's a pretty awesome story so far. And like I said, with the next preview 4 and others coming, they're actually, they're catering to a lot of needs for people. When the first preview of Aspire came out, everyone's like, "Oh, great! But what about these other 3,000 other ideas?" Like it was mainly just to make a local development experience better. But like even that the dashboard now, people want to host their own dashboard in the cloud for some reason. When It was not meant to live in the cloud. It's not there to compete with App Insights or Prometheus and Grafana or Datadog or any of that kind of stuff, right? It's meant for local, but sure, you can. Someone went to the effort to have it containerized and hosted by itself. But yeah, so in a nutshell, decent sized nutshell, that is .NET Aspire, right? It is for your local dev experience, and it is quite good. What about deployments? Yeah, you're waiting for that already, right? Yeah. So there's nothing in .NET Aspire that helps you deploy your app to the cloud at all, right? It's got no right-click publish option, even though in Visual Studio there is something coming for right-click publish within Aspire, but you know, that's just for dev experience rather than doing the real thing, because we don't like right-click publish from a local machine to production, okay? But what you do get is a manifest. I'll show you how your app host can be turned into a JSON file that really describes everything. You know, all the services that you've added in, the dependencies between them, all the configuration, all the containers, all the things that you want to run as part of your distributed app can be described in a manifest. And that manifest can then be used to deploy to Kubernetes or Azure Container Apps, or you know, you can manually parse that and do something with it as well. Or you can completely ignore it. It's fine. You can click ops and do everything by hand if you wanted to. But yeah, your best friend in this scenario is the Azure Dev CLI. So is that something that people have used yet? Maybe, yeah. So the Azure Dev CLI is really, really cool, and especially with the Aspire manifest. I'll show you how that works in a sec. To take this manifest and create an equivalent setup in Azure Container Apps. Now, if you're using Kubernetes, you can use another open source tool called Aspirate. So it does pretty much the same thing. It looks at this manifest file and works out all the deployment scripts and stuff for Kubernetes. You know, if you're really up for it as well. Now, the easy way to do this is you go and do .NET Run, tell it to use a specific kind of publisher. I never knew you could do this, but hey, cool. And just tell it where to store that manifest file. And I'll show you what it looks like. But then, quite easily, to take your Aspire app and get it out into Azure, you can run it with 3 commands. So you're going to auth login, you initialize a dev CLI project, and because I've got too many subscriptions, you have to specify the actual subscription where you want it to go into. And just like Docker compose, there's an up command, and you know, yeah, I think we've got time. I'm going to run this live, but yeah, I'm going to run this live. Let's do it. Just quickly want to clean up some files and show you how that looks. What's the quickest way to get there? Go here. No, not that. That one. Any questions so far? Any questions about, can it do something that I didn't explain? Yes, Barbara?
Can it deploy to somewhere else?
Can you deploy it somewhere else? Yes. If you can figure out how to read the manifest file, or you just do it by hand. I mean, really, it is just APIs. You set up the configuration between them, and yeah, it's not that much.
How does that work with the routing that's already been defined inside, where it's just HTTP?
Yeah. So okay, first question was, how do we deploy a .NET Aspire app to somewhere else other than Azure Container Apps? The story is not fully complete yet. Azure obviously is first-class citizen out of the thing, but you can deploy it anywhere else, because it is really just going to be manual work for you to describe what resource to deploy your code to for an API, or you know what dependencies you need to spin up, like a SQL or Redis. You know, we do that stuff normally anyways, right? We have our cloud architecture explained, we build our applications, and we ship those artifacts onto the cloud. So you're going to have to do all that manual work still in whatever place you want to host it in. Just with the service discovery stuff, you wouldn't need to change your code. You just have to provide the app configuration. So there is a convention in there which I glossed over, but there's a convention to say what the host name and port number is for a particular service that application needs. So you can actually provide it just configuration for it to know who to talk to. So because when you do the add service discovery as part of the service defaults, it reads that configuration and then it sort of takes care of the HTTP message handler to override that logical name with the configuration that you provided.
Okay.
So it's a bit involved, but you can still take your Aspire app and deploy to AWS, GCP, or wherever you want.
Yes, and now I don't just want to have it elsewhere, I also want to have a service that's possibly not supported yet.
Oh, okay, so you want to, so the next ask is, you've deployed it somewhere else, but
so
you...
I can only, I have that service in that environment, and it's none of the ones that you...
Executable or container?
There you go. So the answer is going to most likely be containers. So if your service that you want to run is available as a container, that'll be the easiest thing to use to spin up and add into your application. But you can also run other executables, depending on what service you're trying to use. So if you have another example, then we can work through it.
OPC UA?
Sorry?
OPC UA?
I have no idea what that is. OPC UA.
Open something unified architecture is a standard to talk to on machine levels.
Oh wow, yeah, that's going quite deep. Yeah, I haven't done that before. But yeah, maybe that's something we can talk about later. But that's not something I've got much of an idea about. But that sounds pretty cool. Yeah, you can obviously log issues on the GitHub, Aspire GitHub, if there's something you need. But yeah, I think they'll cater for the more common uses for now. Yeah, but all right. So I'm going to quickly just delete a bunch of stuff, and I'm pretty sure I deleted the right stuff. Good. Okay. So in Visual Studio already, right? I have gone and done a compile to generate that manifest file that I mentioned before. So you can see here it is going to describe those resources that I've added. So here's a cache. So it's of type Redis v0. So it understands what Redis is. I've got a sample API, which is a container. And here's the image that I described before with my port number overrides. Same with the SQL Server. I've got a password that is being inputted. It's got the standard bindings. You can override these if you wanted to. Here's the database, the weather API. You can see here's some extra environment variables that it's describing. So yeah, if you wanted to do this outside of the dev CLI, you need to probably write something that can parse and understand this. Maybe there's going to be NuGet for it that you can use. I'm not sure if there is just yet, but you can see here with the services, weather API, HTTP or HTTPS bindings, you can then provide this configuration to your app in AWS, GCP, and tell it where the weather API is actually hosted. And then inside of your code, you don't have to change anything. Okay. Same with this other sample API. So it will go and look up that URL for the sample API endpoint, which was up here somewhere. That one there, right? So it'll resolve it somehow for you. So yeah, then getting a more complicated app, this manifest file is going to get nice and busy. So okay, I've got cleaned up a bunch of stuff, and let's make this a bit bigger. So AZD auth login is going to be the thing I need to do, and hopefully I don't have to do 2FA. Oh, great, good. So we're done. So now I can do AZD init. Hopefully that's still my history. Okay, so I'm going to give it my subscription ID, and the cool thing is AZD will go, all right, select a template, or magically figure out from, I don't know, AI or whatever they use, what sort of application is in this current directory. So when I just let it scan my app, give it a moment, and it's going to figure it out and say, okay, I found a .NET Aspire application, and we reckon we're going to deploy it with Azure Container Apps. Yep, cool. So cancel and exit, or let's go ahead and initialize this. Oh, it actually knows now the services that I've described in my Aspire app host. Which one do I want to have as the ingress point for my distributed application? Well, let's choose a web front end. Don't think you want to choose a SQL database, doesn't make sense. All right, so good, let's go. So what I'm going to call this Melb.net live, yay. All right, and that's it. It generated a couple of things. So I actually can go now, read the notes, do other things, set up my CI/CD pipeline, do all the hard things. Or, you know, I want to get the stuff up and running from my local machine, just go AZD up. And you'll see what it's done. It's gone and created this azure.yaml file, which, yeah. Basically, it's just a little bit of information to say, hey, where's the CS project file? That's not very exciting. But the other thing it does, will that open up? Let me just open up the folder. It actually does create this .azure file, folder with a bit of extra config, not that exciting there, but here's the project name that we gave. So all the environment variables and other things I want to use are in here. So hang on. I'm pretty sure Southeast is not going to work. Maybe I forgot to delete something. Yeah, I forgot to delete something. So for some reason on my subscription, Southeast Azure Container Apps is not available. What did I not delete? Okay, let's do that. Again there. I do have a pre-prepared one, by the way, if this doesn't work. That should be it, yeah. Am I in the right folder? .NET? Yeah, I'm in the right folder. Cool. Confirm that one. What did I call this? Melb.net Aspire Live. Okay, AZD up. It's reading something from somewhere. It's supposed to ask me for the region. Yes, it's not supposed to do that. Am I in the right folder? Aspire? Yes, I'm in the right folder. What's it doing? Oh, hang on, is it in here? No. I know it's probably going to fall over again. But that's okay, because I do have it prepared. Oh, I'll work this out in a minute and I'll let you know. All right, so that's the easy way. We punch in these commands and we'll go and do the sort of initialize part. And you see here it's going to look for code in our current directory, choose Azure Container Apps, expose the front end to the public, give it an environment name, and then it says run AZD up, which we go ahead and do. It chooses the right subscription, which should have been interactive, should be Australia East. We can see that it goes and provisions all these resources and gives us the URLs to our published applications. Cool. So now I want to show you, yeah, red. So here's one I did earlier. Oh, got too many. Aspire Live. I think it's this one. Oh yeah, that's the one that should work. Good catch. Okay, so has anyone not used Azure Container Apps yet? Okay, a couple of people. So this is pretty cool. So in the resource group, we have a Azure Container App environment, and it really is under the hood Kubernetes, but we don't have to deal with Kubernetes ourselves. It's a fully managed Kubernetes setup with a VNet and all sorts of stuff already just done for us. It's got Kida and Dapper built in, which is obviously outside of this talk, but you know, we can go and see, here's the apps that we've actually gone and spun up in our environment. So here's that sample API, the SQL server, the weather API, the web front end. So if we go look at the sample API, we can see that it's got a .internal as part of the hostname. So if I try and click on this, it can't go anywhere. It doesn't access it because it's not publicly exposed. But we can actually go and look at the container that we are running here. You can see that it's that sample one. Here's a tag. You know, you've got other configurations, environment variables, a whole lot. Everything we want about the container apps and all that configuration that we provided for, let's do this one a bit more interesting. If we look at the environment variables, we'll see here that it's gone and done that manual configuration for us to say this service runs on this host name and this port. Because if you look at our environment, there's no app host. The manifest file doesn't have an app host. So from Visual Studio project, right, this app host project never gets deployed. It doesn't go to the cloud. It's just for your local. Okay? So yeah, this front end app, if I go here, I can click on the link there, click on it, bang, there's the same app that we had before. And now you can see it's actually just running in Azure. Same thing. And it just works. Right? So if you want to try and copy that URL, or you want to scan that, you guys want to try that out, just click on it, make sure it actually works, right? It's not smoke and mirrors. A couple of phones, all right, I'll give you a sec. I think next time we'll have to have a more of a challenging app to use. All right. Yeah, how high can you get in 1 minute? Yeah. All right, let's move on. Okay, so there's the app. It's running in Azure. Boom, Azure Container Apps. Now, the one thing I really want to point out is, right, in our Aspire host, I wanted to show you here that when we're adding our SQL Server, right, so adding a SQL Server container, but in the next version, what we'll have is the ability to do it like this. You can add SQL Server, but when it comes to publishing time, you're going to publish this as an Azure SQL database. So you can have the local and cloud variants of the resource, which is quite nice. It's not available in P3, or in Preview 3. In Preview 4, which is hopefully coming soon, you can do that. And then, of course, all the other things comes along. So not just for SQL Server, but pretty much all those other ones, you can have a local and a cloud variant to describe in there, so that by the time it generates the manifest file, it knows to generate something, or the AZD will know to generate an Azure resource, rather than in this case, it's gone and spun up the SQL container, just not quite the same as an Azure managed SQL. Okay? Hey, but it still works, which is great. So for now, I'm still very happy. Cool. So back on, deployments, the better way. You saw the easy way. The better way is to enable a preview feature and use a command called infra-synth. So what that's going to do is going to generate all the bicep files and stuff that you need to get this thing up and running, but go and fine tune it so that you can maybe add more security, fine tune the ports, memory and CPU size, all that kind of stuff. Right now you don't have that ability through Aspire, right? It doesn't need to care about that, but so then you go and set up a proper CI/CD pipeline as well, because really Aspire is just for your local dev. It's not to get it out into production. So don't do what I just did and think it's the right thing to do. But that's a lot more involved, so that's for another day. I already showed you the cloud native app running in Azure. So in summary, one click starts all. It is awesome. It's true. You saw it working. The local dev experience is pretty awesome again. Service discovery, debugging when it works, and the observability is awesome. We never had that easily available, but now we do. The orchestration, but I said, hey, we're talking about containers and so forth, but there was no Docker file, no compose files yet, but you still would use them when you need to create your own stuff. I think in the next versions there are something coming like compose, or being able to run a Docker build as part of the orchestration. Okay, so in P3 that's not there, but it might be in the next one or the one after. So there is something a bit more lower level coming in, which is going to be pretty cool. So it's not that you have to not worry about Docker files or compose files anymore. It's just that it's not available in this just yet. It's not just for microservices. It's literally, I would use this for almost any app now. Anything that needs a database or storage or a queue or whatever, I would put Aspire in, even just if it is for getting the logs and the traces out of my app. It'll be quite nice. It's a great productivity boost. You can get up and running super quick. And of course, there's a lot more coming. Now, at the start, we said, hey, service discovery or all these things are a bit of a pain. But now with .NET Aspire, it's a lot less painful. It's still there, but less painful. Now, if you want to get the code for all the demo app stuff that I did, there's a repo. So it's a bit of work in progress as well. I'll keep adding to it, so it might change over time. But feel free to grab it, start there, put up an issue or a pull request, I don't care. It's all there to have a bit of fun. And with that, thank you very much. Thanks, George.
Let's give away the books.
Let's give away some books, yeah.
How about the people look for job first?
Yeah, that's right.
People looking for job because they have to get a job.
Go straight to the
You
deep
now
end.
can get a job. You now can get a job. You can get a job. He's looking for a job. He's looking for a
Hey,
job.
George, can we get a selfie with the crowd?
Oh, yeah, sure. But
I like this room. It's pretty nice to work in
now
here.
we have how many left?
Huh?
How many books left?
Oh.
We have 7 books left. Who wants the book? Who wants the book? Ours works. See? You still have 2. Who wants the left ones? Good? Okay.
Oh, we got one here.
She wants the book and she deserves because she organized this meetup for a long time.
Yeah.
And now you don't say that you don't know Kubernetes.
Hey, George, can we get a selfie, man?
That's good.
All right. Can everyone? Oh, man.
Come on,
We're all too tall. Barbara's. Hang on.
Barbara.
There we go. Hey. It's been great, everybody. Thank you very much. Yeah. If you want to know more, we've got a few more minutes before we go, I guess. Yeah.